Good day, this is Professor Timothy Kentop. This is our last item analysis for the final module in CSC 465 Systems Security. From the initial results, we had a couple of students that had very low scores that threw the average off. But if we take those out, students did fairly well. You'll notice that in terms of the difficulty ratings, 3 were rated easy, 5 were rated hard, and 13 were rated medium. And that's a fair breakout for what we're interested in seeing on a first assessment. You did see that there were very few that were rated poor or cannot calculate, which means that there was a wide range of student answers on most questions. We're going to start with the items that were the most challenging and work our way up. When we see multiple choice that were worth 1/4 of a point, where the entire class, the average was 1/4 of a point, that means everybody got this correctly. And so these questions are encouraging. This question, multiple answer question, is worth at least 1/2 a point. And so the fact that there's only half credit here means that students missed a number of things. If we move on up the scale, multiple answer of 0.44, or multiple choice, we had a couple of multiple choice that were worth half a point. These 3, most students did well with. So we're not going to spend time reviewing these 3 and these 2, but we'll step through the rest. So, true, false. Effective professional business grade security is difficult to achieve and rarely cost effective. False. We set up an entire Active Directory domain infrastructure in 90 minutes, live, in class, to do something that could be used to structure the data and security for an entire Fortune 500 company in 90 minutes. It's both effective and pretty straightforward to do. So that statement is false. I think what's more true is that people are not aware of what needs to be done. Name association failures. You are hired to recommend changes to enhance the reliability and security of systems on a client network that frequently loses connectivity to the service provider and DNS they host. When this happens, the name associations for resources on the local network fail, and users cannot connect to these named resources, even though both servers on the local network remain connected and working. What single change can you make on each client to ensure that name associations for resources on the local network persist, even when access to the service provider and DNS services are lost? So you lose the internet connection, but the local network is still working. The preferred answer is set up each server address and name in the hosts file. You don't have very many systems, but you do have frequent outages with internet and the DNS, and you need to maintain access on the local network using name associations, and that's what hosts is ideally suited to provide. By registering each server using ipconfig register DNS, that updates the DNS record in DNS, but if they lose DNS, that doesn't help. Changing the DNS server listed in the IP to an open source DNS server, 1.1.1.1 or 8.8.8.8, isn't going to resolve the local name associations on the DNS that they need locally. The goal isn't to browse the internet. The goal is to provide persistent service to the local network. And what's happening now is that they don't have their own DNS capacity. This is another reason why DNS would be good to have locally, So the last answer, enable NetBIOS over TCP/IP to allow use of WINS to replace DNS. That is a horrible choice. That's something you never want to do. Basically, the best answer would be host your own DNS service with records for the local systems. But even if that local DNS is down, a hosts file would solve the problem so that even without any DNS running at all, people could see it. HTTPS is defined as blank and is currently implemented using blank. Choose the paired responses below that complete the statement correctly. HTTP over secure sockets layer is the definition and is currently implemented by using TLS. SSL was retired, deprecated. It is not used anymore. It is compromised. It is vulnerable. It is insecure. SSL has been replaced with TLS. So even though it's HTTPS, and that means over secure socket layer, TLS has replaced SSL. If there were any logic to how this works, it would be called HTTPT, TTPT, but I think they just, in order to avoid confusion, they kept it the same, and they just said, hey, we're just retiring SSL, and we're going to use TLS instead. TLS is a similar but more bulletproof technology. So it's kind of a tricky thing, but that's something we've mentioned in class, and we've also mentioned in the study guides. You are directed to implement HTTPS to secure web sessions. The most common and cost-effective option is to configure secure sockets layer. That is false because TLS is the common and cost-effective option. It's not cost-effective if it doesn't work. SSL has been compromised. The Heartbleed exploit was a good example of something that was used to attack secure web systems, in particular Linux-based web systems, Heartbleed. And it took advantage of an exposure in SSL, and that accelerated the retirement of SSL. So now TLS is used. This is our first multiple answer question. Subject matter experts in systems security recommend implementing a local system to perform DNS for a number of reasons. Which of the statements below reflect the primary security benefit of local DNS? Well, you have direct secure control over name associations used to access resources in your local network, and that's major. And you have a cache of browsing and email activity. So these are primary security benefits. So when something goes wrong with email, when something goes wrong with online apps, when something goes wrong with web browsing, when you're being exploited or hacked, you can go to the DNS cache and get additional information on the resources that are being engaged online. And that's no small benefit. So having direct control and security over your own records and being able to see what's going on, those are the primary security benefits. Much quicker web browsing and email responses on screen, that is a significant benefit, yes. But that's not a security benefit. The question reads, which of the statements below reflect the primary security benefits? So quicker browsing and email is definitely, better productivity. That's certainly a plus, right? The ability to override the entries that are corrupted in the hosts file? No, if entries are corrupted in the host file, those override the DNS. So that's not an option. The means to secure NetBIOS over TCP/IP against attacks. DNS has nothing to do with NetBIOS over TCP/IP. And it doesn't secure NetBIOS over TCP/IP against attacks. NetBIOS was retired because it is vulnerable to attacks. So there you have it. Those are the two primary security benefits. Match the technical control with the system's component it is designed to secure. 802.11i, that has to do with AES encryption, TKIP. Basically, it replaced WEP, wireless enhanced protection, which is no longer really much protection. WEP was retired. 802.11i, the encryption that you use with wireless connections, that's what secures the wireless. 802.1x is mobile device access. In point of fact, you can use certificates and two-factor authentication to authenticate mobile devices for access on the local network. So managing mobile device connections on your wireless networks is a security challenge, and one of the ways to tame the beast is 802.1x, but it has to do with two-factor authentication, and you can use certificates with EAP. So basically, it's like a 1-2 punch. IPsec tunnel mode. Tunnel mode encrypts connections, where transport mode authenticates connections. Transport mode is faster. Tunnel mode is slower, but more bulletproof. It encrypts the entire packet, not just the payload. Dhcp scope criteria, that's connection specifications. So there you have the matches for the 4 types of security measures. Which advanced DHCP scope parameter? So you have basic DHCP scope parameters like DNS and the gateway setting. The advanced DHCP scope parameter that can be set to reduce the likelihood of replay attacks. That has to do with basically network-based time sync servers. So there's a protocol called NTP, and there's a pool of NTP servers. It's option 042. That's the one that secures against replay attacks. The reason that secures against replay attacks is that it keeps all the systems on the same clock in sync. A replay attack basically takes advantage of differences in time. So you capture somebody's login on a system that's running fast. You find a system that's running slow and you replay it back into the stream to break their password. Replay attacks were basically devastating, and it was difficult to prevent, but this is one simple way of handling it. Keep everybody on the same. It also, running NTP servers is also a great way to handle the prerequisite for Kerberos implementation. Kerberos requires no greater time difference than 5 minutes between systems, or Kerberos breaks, and then the system doesn't work right on the domain. But the first thing you look at is the time sync, and oftentimes you'll find a system clock that's 5 minutes or greater in difference, and that's part of the problem. And that's the other part of Kerberos. It's defense against replay, right? Unrelated systems. You are conducting a review of systems logs and discover that temporary memory allocations on a series of otherwise unrelated web servers are being used to transfer related user data between systems. So you have a set of user data, and it's basically skipping between systems out on the internet, like a rock skips. This is the description, the layman's terms, the description we gave for cross-site scripting attack. A buffer overflow attack wouldn't involve different web servers, and a SQL injection attack would involve a single SQL server. It wouldn't involve multiple servers. So, yeah. Scenario A, a DHCP scope parameter. Which advanced DHCP scope parameter can be set to reduce the attractive nuisance of network discovery? When we talk about network discovery, there are two mechanisms. One is NetBIOS over TCP/IP. The other is LLMNR, which can be disabled with a GPO. NetBIOS can be disabled with option 46 when SNBT node. It's not the server's option, and it's not the hybrid node. Hybrid node keeps it in NetBIOS over TCP/IP mode. You want B node, which means that it's not going to persist in NetBIOS. It's not going to stay in NetBIOS mode when it connects. The other modes are problematic that way. Option 45, NetBIOS over TCP/IP, NBDD, that's the wrong entry for this. It's not the feature. It's the WinSNBT node type that needs to be set, not the NetBIOS over TCP/IP NBDD. NBDD is something else, unrelated. So anyway, it's 46, option 46. It's part of the solution that we did for this module. So if you haven't done the solution for the module yet, you should complete the solution for the module before you take the retake, before you engage the retake. Performance protection. Have a session. So you're asked to implement a method to protect network traffic between many systems on a local network. The method must work well under conditions that require more speed and large amounts of time-sensitive data. Which method is best suited for this purpose? That would be IPsec transport mode. So IPsec is ideal for large numbers of systems that need to interoperate with secure tunnels between systems. And locally, that's a great way. IPsec can also be used between sites with VPN connections if there's an IP network. So Kerberos would not be Kerberos EAP TLS. That's a bogus answer because EAP TLS has to do with 802.11i. No, 802.1x. EAP TLS is a form of encryption, but it's often paired with two-factor authentication used to grant access to mobile devices. Kerberos is something different. That's the protocol that secures authentication across a network. It was developed by MIT and was part of a Department of Defense security project. But basically, that's associated with enterprise security account management models, specifically Active Directory domains. So that's two different things. HTTPS and TLS, that would be good if you had like a web server out on the internet and you had lots of clients out on the internet that were accessing that one system. That's not the scenario here. You have many systems on a local network. So you have to implement or enforce IPsec. IPsec can be implemented with GPOs in a domain. This isn't necessarily, there's a lot of elegant things you can do with GPOs and certificates, and you can insist on different levels of security and connections outside the local network, but that's not, the idea here is that you want to be able to automate broad scale a large number of connections between systems. And that's where IPsec is ideally suited. Okay. Kerberos benefits. Kerberos version 5 is often used as part of an Active Directory domain implementation to enhance network-based authentication. What are the primary benefits of using Kerberos rather than legacy methods like NT-LAN Manager, NTLM? Select all that apply. Well, we've already mentioned the time sync issue, so Kerberos works in concert with, so it's designed to work interactively with, time synchronized systems to defeat replay attacks. And basically, the encryption, the hashes that are used, the encryption methods, if you have privileged accounts that have longer passwords, the level of protection for those accounts is significantly larger. The size of a rainbow table that a hacker might use to try to crack that password is out of reach, except for nation states. By nation states, we mean countries, whole countries that have entire arsenals and research departments to commit to that kind of thing. Other answers include the clocks for all devices and systems on the network are synchronized. That is something upon which Kerberos is dependent. That's not a benefit of Kerberos. So Kerberos is dependent on this. UPN logins, that's a benefit of Active Directory domains, but that's not a distinct benefit of Kerberos. And it says a client can request a ticket granting ticket to broker proper access. That's how Kerberos works. So this describes how it works, but that's not a benefit of Kerberos. That's just a functional aspect of Kerberos. So this is how it works. Those are the benefits. These two are not, this is dependency. So Kerberos is dependent on synchronized clocks. And UPN logins are possible without Kerberos. Okay. So this is the last item that we're going to review before we skip over these three, and then we'll pick up the trail again here. So ordering steps to implement. So this is something we covered in class, and it's in the study guide, and it's basically the steps that you followed for your solution. The first step is to purchase a managed switch to connect devices. If you don't have a managed switch, you can't do IP helper, which is the next step. Configure IP helper to anchor the source of network address leases. Network addresses are dynamically leased by Dhcp to devices so that no two are exactly alike. The leases are organized and managed in a manner where no two devices have the same IP address. The third step is to specify network operating criteria on a dedicated Dhcp server. So you basically say, we're not doing NetBIOS, we're using these time clocks, we're using these DNS servers. And it says define the association for local reference. So you're defining the name associations for local reference in a custom DNS zone locally. That's the fourth step. And the last step to lock down infrastructure is to implement Active Directory. 2 domain controllers, 1 DNS, and a WSUS server. That's the last phase, and that makes you a serious threat, a credible threat when it comes to an organization that possesses technical assets. If you have just those things we did in class, you have infrastructure that is defendable and stable and reliable. Okay, so we're going to skip over these three We're going to pick up the true false. IPsec tunnel mode protects the entire IP packet, not just the payload inside the packet. That answer is true. It is transport mode that only protects the payload. Here's a half-point multiple choice. You've been hired to assess and recommend security measures to improve the applications developed by a new software engineering firm. So this focus of the question is about software security. In recent months, it has been discovered that a number of critical solutions can be exploited by using buffer overflow attacks. When you inspect the source code, you notice that a best practice is missing from coding methods used by the team. Which single method listed below would most likely result in an immediate improvement and greatly reduce the likelihood of buffer overflow attacks? It's input validation. Another term for this when you're developing code and solutions is exception handling. You have a huge amount of data, it doesn't match with the criteria that you're supposed to receive. What do you do with that exception? That's what input validation is really all about. So another way of rephrasing input validation is to say exception handling. If you have built-in methods of validating the input against a known data type and a known size, anything outside of that you can just drop. And that's easy to code, but it's often omitted. And that's the single biggest problem with buffer overflow attacks, is that too many developers leave the barn door open. They just don't do it. Okay. Single best practice in software security. So once again, in our study guide and overall, if you are validating your inputs and your outputs and the process along the way, you're using a lot of print statements as you develop the code, and then you're remarking those out or removing them altogether. Another description for that, test as you go, validate as you go, is called test-driven development. This probably reduces, you're getting what you expect. So your inputs, you're validating your inputs, you're validating your outputs, and you're validating the process. When you are validating inputs, what's included is using a variety of bogus inputs to see what happens to the process. So test-driven development includes checking for, exception handling, right? So exception handling and input validation is actually part of the test-driven process. This is the broadest term of software security you can, the broadest control, the single best practice, the single best method to reduce software security exposures. And within test-driven development are additional practices, such as, checking for bounds, exception handling, validating inputs, and so on. It's all a part of the test-driven development. So those other components are embedded in test-driven development. And this is stated plainly in the study guide. All right. What single character used in a SQL injection attack can return unexpected data? It's the tick mark. What are we saying? If I have a login and I go to login on a website, oh, no, I was already logged in. Let's go to my campus. When you have a database on the back end and you have an input field on a web application, sometimes a single tick mark can return all sorts of weird data. I'm not encouraging you to do that, but if you wanted to check for web-based application security, you could basically enter a single tick and hit the enter key and see what happens. And if you get some gibberish on the screen, that's not a good sign. So there you have it. This concludes our item analysis for our final assessment. Please reconcile promptly before you retake. And if you haven't completed the module solution, there are plenty of concepts and issues that are embedded in the assessment questions, the items from that solution. So please be sure to complete the solution before you attempt your final retake. I'm available as needed for anything else. Good luck on your retake and your final exam.